All right, 1-2, day 2. Jumping into an example right off the bat. I think that's all we have today are examples. It is. You're not learning anything new. Well, I guess that last one's a little bit new, but just examples. Find the smallest positive coterminal angle to 827 degrees. So this is what those last two questions were asking. I don't know how many got them right, but I will show you a nice quick way to do it. So. Okay, so we had an 827 degree angle created by that rotation. So that means the angle started here, rotated counterclockwise 827 degrees. So let's see what that would look like. $360. $720. How many more degrees do I have to go to get to 827 if I'm at 720? How many? 107. So that's going to take me into the second quadrant because that's 90 at the top. Go a little bit far. Okay, so there's 827 degrees. What we want is the smallest positive one. So the angle that starts here and stops there with the least amount of rotation. So how many degrees did we just figure out it was from here to here? What is it? 107. Okay. What's going to be our process so we don't have to draw all this out to get that? All essentially we need to do is start at the 827 and then keep subtracting a full rotation. How many degrees in a full rotation? 360. So we're going to back up one full rotation. So that's at 7. Can I unwrap one full rotation again? Yep. And still be positive? There's my smallest positive coterminal angle. So not necessary to do all this, but you can see why it works if you just keep unwrapping. So if we use that shortcut, can you find the smallest positive coterminal angle to negative 550 degrees? Well, what are we going to do with that one? Add 360 until we get into the positives. So if you already are positive, you subtract. If you're negative, well, you want to add till you get to a positive value. Negative 550 plus 360 is anybody good with that in their head? 190? Or negative 190. So I got to add 360 again. Because I'm still negative, I'm looking for the smallest positive. This should do it. Positive 170? Hard to do that subtraction when it's upside down in your head. So there it is. So coterminal angles, to create them, all you're going to do is add 360s or subtract 360s. Okay, number 2. Can you sketch the given angle showing the rotation. Find two other coterminal angles one positive and one negative. So I'm not asking for the smallest or the largest. It'd be impossible to get the largest. And name which quadrant all of them land in. And let's go with, I think one of these ones. Let's go with negative 105 degrees. So first of all, can you sketch that showing the direction of the rotation? And tell me which quadrant you land in. So all rotations start on the positive x-axis. Rotating negative 105 degrees. Negative goes
Down.
clockwise, down. Got to get to 105. Well, remember your 90s here, 90, a little bit more. So quadrant, start with quadrant, because they're all going to land in the same spot. What quadrant is that again? 3. 1, 2, 3. Now our coterminals. How do I create coterminal angles? Start at your angle and then either add 360 or subtract 360. So if I want to get to a positive one, I better add. Take 105 off of that. Or, yeah, 255. If I wanted to add 360 again, I could create another coterminal that's still positive. There's an infinite number of correct answers here for the positive and the negative. Just quick enough to do it once and stop. The negative one, create another negative coterminal. You just got to subtract 360. So negative 105, subtract 360 more is going to be a negative 465. Everybody's good? Number 3. I think we did this yesterday. Write an expression that gives all angles coterminal to, let's go 20 degrees. Remember, all we're doing to create coterminals is adding sets of 360 or subtracting sets of 360. So the way you write that expression, the way I did it yesterday, I don't even know if you followed it or not, you start at the angle where you're at, and you either add or subtract sets of 360. And we show that by putting little n here. And then we got to tell what n can equal. So when n is a 1, 360 times 1 is just 360, that's adding one set of 360 to 20. If it was a 2, you'd multiply, you get 720, you're adding 2 sets of 360. 3 would be 3 sets of 360. What would a negative 1 represent? You're subtracting one set of 360. A negative 2, you'd be subtracting 2 sets of 360. So this expression works if, only if, n is what kind of number? Negatives aren't really whole. Wholes are the 0 and up. No decimals. Integer. Integers are the positives and the negatives with no decimals. If n is integer. N is an integer. Draw a ray from the origin. Through the point. Show the rotation. Find the distance. As an exact value. This one comes out exact, but I want you to do exact in the homework. Because I believe that's what you're going to find in the back. Alright, and our point we're going to pass through is -2, 2 square root of 3. So what this is giving us is the point that our terminal ray is passing through. So when we sketch this, our ray is, our initial side is here. The terminal side passes through this point. Where is this point at? Well, it's left 2. And I don't care what this actually equals. If you want to actually see what it equals, you can type it in your calculator, 2 square root of 3, hit enter, and get a decimal for it. I'm not quite sure. I think it's like 5 point something, maybe. All I care about is that it's positive. So I get it in the second quadrant. So our terminal side passes through that point there. There's our angle of rotation. So I did the sketch, showed the rotation. Now it's asking me to find the distance from that point back to the origin. It wants that distance. So you can go ahead, because the origin's 0, 0, you can do distance formula, which is fine. Or I like to see this as a little right triangle in Pythagorean theorem. Because I know this side is 2. I don't care that it's negative, because the distance is going to come out positive. This side is 2 square root of 3. Now I can quickly set up Pythagorean theorem much quicker than I like that subtracting the x's and the y's and the squaring and the square root. Just quicker. So if I set up Pythagorean theorem, 2 squared plus 2 square root of 3 squared equals my distance squared. Little Pythagorean. Or, and remember here you're squaring both parts and multiplying together. So 2 squared is 4. Square root of 3 squared is 3. You get 12 then. Square root. And again, if that came out like 24, I want you to do the simplest radical form. But this one happened to come out nice. Then a couple of thinkers on the end. Can you think today? Yeah, well, think. Cool. Carson, you ready to think?
No.
No. I'm going to give you a cupcake problem, and I'm going to give you a tough problem. Cupcake. Ready for the cupcake? Okay, we've got a tire that's making 90 revolutions per minute. Got a picture of that? Know what that's saying? Making 90 complete turns in 1 minute. My question, how many revolutions is it making per second? What's our process? Cupcake problem. Anybody got it? Divide by 60 or multiply by 60? Divide. Well, second hour said, or first hour said multiply. I'm like, really? I had to explain the error of those ways. It is divide. Because you know in 1 minute there's 60 seconds. So I want to take this full minute, divide it into 60 equal chunks to see what's in one of those little chunks. So 90 divided by 60. Let's see, that goes into their 1.5 revolutions per second. You can also use the old school T-box method. When you've got more than one thing, which is coming in the next one, more than one reduction to make, I guess it's called. T-box. Say what you're starting out with. I'm starting out with 90 revolutions per 1 minute. Stoichiometry is exactly what it is. So those that had chemistry last year. Oh, last hour?
Yeah.
Or, so then you know what goes over here. What's the conversion for minutes and, what do we got, seconds and minutes? 1 minute, 60 seconds. You want your minutes to cancel? That's such a handy little tool, that stoichiometry. And you can see you multiply across the top, you multiply across the bottom, and you divide your results. So you get 90 over 60, which is what we had. Okay. You don't have to use that method, but it's very handy. So this next one, so it's going to be a little tougher. We've got a propeller that's making 600 rotations per minute. Can you tell me how many degrees per second it's spinning? Go. Try that. You don't know. T-box. T-box away. Write down what you're starting with. Then think about what you want to get rid of and what you're trying to get into. I can tell you it's 2 conversions. You can also do it with some common sense, too. Yeah, I didn't have that either in school. I'm getting better at it. I was all about process. Give me a process. I can follow a process. We did have people in second hour think through it logically, give us a couple ways to do it. Be nice if you could get there too, a couple of you. Right, Carson? He's not even trying. He's waiting for somebody to tell him how to do it. Slacker. Did I call it right? Yeah, thought so. Of course. You try it? You tried it. Got something. Drew the T-box. Starting.
Put some numbers in it.
Got some numbers in it. Anybody get an answer? I want to check. What do you got? You are correct. Did you do T-box or did you logic?
6,000 divided by, or 600 divided by 60, multiply that by.
That's what I did.
You did that too.
Exactly what I did.
Exactly. Okay, let's see where they got that from. T-box will tell us. T-box is awesome. 600 rotations per 1 minute. Did you get that far, Crow?
Yeah.
Yeah? Okay.
Not an extra stuff in there.
Extra. You even got extra in there. That's good. It doesn't matter. I don't want to have rotations and I don't want to have minutes. It doesn't matter which one you start with. Let's say we want to get rid of the minutes first. I want to get rid of minutes and I want to end with seconds. So we put our conversion for minutes and seconds here with the minutes on top so it cancels and seconds on the bottom. So 1 minute is 60 seconds. Okay, so minutes cancel. So right now I would be at rotations per second. Well, now I want to get rid of rotations and end with degrees. Well, think about a rotation. How many degrees? 360. So my next part of my T-box is one rotation, and I want rotation to cancel, so it goes down here, is 360 degrees. So you multiply across the top, multiply across the bottom, then divide those results. Or I can reduce here and do all my stuff, but you will get 3,600, and what you have left, degrees per second. Look at that. We'll see how you do with the problems at the end of the section. Evens, skipping, 58.
Yeah, you were slacking on those skips those last 2 days.
What?